All right, it's Monday, September 20th, and I'm not going to post new assignments because you've got them all. You've got everything laid out for the quarter, and you might be working on this guy or this guy or this guy, but we're not going to add more. We're just going to do them in the time that we have. So today I'm going to look at an example from this, because I've already posted 2 videos about the deck of cards. A lot of people have it done, and a lot are working on it. And this functions and exceptions thing, it's important on its own, but it's also what you're going to use for this. So once you get the idea, you can use it on the project. And we want to make sure you do have the idea. Over here, the first part is kind of too easy. It's functions, meaning you have some stuff that we've already done before, like printing hello world or whatever. And then you give it a name. You say, hey, this thing where we get some stuff and print it, we're going to call that message, or we're going to call that, hello or something. And then you can run that function to make it happen. The reason why you might do that is to use it multiple times through the program and then not have to copy those lines. Or just give it a nice label, and then you or somebody else could run that chunk of code by calling the name instead of trying to find it or whatever. Just like naming a variable instead of using the number, if you name some process instead of using that code, you can just give the name and it happens. Functions and parameters, this is when it gets good. This is when you actually send some value to the function and then it does something with it, maybe spits out an answer back to you, or maybe prints on its own, whatever. Now that's not new. Parameters are just the things in parentheses that we've already used when we use print or input or range, for example. They always have stuff in parentheses that tell it what to do or how much or whatever. But you can make your own ones of those. I'm going to use as an example this one, the print multiple times. And it's going to say, you're going to send us 2 things. It's going to say, write a function that takes 2 arguments, a string and an integer, and prints the string multiple times. The integer specifies how many. So, for example, if you run this function, you give it hi and you give it 3, it'll say hi, hi, hi. Or if we gave it, stapler 5, it would say stapler 5 times. Okay? Whatever the thing and the amount, that's what it's going to do. So let's say I'm going to hit enter a couple times, which you'll often see me do at the beginning of one of these, because I'm going to write some code knowing there might be stuff before it, there might be stuff after it. I want to kind of start in the middle, theoretically. You hardly ever just go top to bottom knowing exactly what's going to be in order. You write something and you're knowing it's just floating there with stuff potentially bouncing around it. So mine, instead of print multiple times, I'm going to call it print x times, because that's a lot shorter and it just feels nicer to me. But they don't care what you name it, as long as it's something reasonable. And then I'm going to call it for, somebody give me a random word. Doesn't matter what. Pineapple. And a number. How many times are we going to say it? 17. Okay, thank you. So this is going to call a function to do pineapple 17 times. If I hit run right now, it's going to say, hey, that function doesn't exist. So we're going to have to make it. But I like to have that first, just to know what our target is. And in fact, that's the only line of code in this one that's loose. It's floating around outside of a function. It's what you call the main part of the program. Later we'll do stuff where we actually give this thing a name, and it's called main. And it's the stuff that's not in a chunk of a function or a class or like a little sub part. It's just floating around in the cytoplasm of the program. So let's say we're going to define what print x times means. And the way to do that is def. Okay, def is short for define, and it's what you do when you're going to do a function. And then we're going to say print x times, or whatever you want to call it. And we're going to say there are two things that this function is going to get. Every time it's run, the other code is going to send it two things. Okay, the first part's a string, second part's an integer, but inside of this function, we're going to give those guys a name to say what they're going to be called. I'm going to call this first one message. That's not a keyword or anything. That's just something I made up, but you want to give it a name that's going to kind of make sense. And then for the second part of how many, I'm going to call that x, because I used x in my name, and I think it just sort of makes sense. But you can use something else, okay? Now, when you make a function, just like when you make a loop or an if or whatever, the key symbol in Python is going to be a colon. And when you put a colon, that means the next thing, which is going to be indented, is inside of this guy. So whatever we type in here is going to be inside of this definition. Okay. And then when we run for next time, it's going to say, hey, let's look in here and do the stuff in this part and go from there. So we're so close. Like, we're one step away, because you don't have to make the values inside of here. When you run this, they're already going to send you what the message is and how many times. So you don't have to like create those variables or give them a value or anything. It's going to be sent to you. So this function is doing a little specific job in its own little world, and it doesn't have to prepare all the stuff. It's just like when you're in the assembly line in a factory, you know, the previous guy on the conveyor belt is going to send something to you, and you do your one thing to that, and then it goes on to the next part of the conveyor belt. You don't have to like create the car or whatever. You just add whatever thing is your thing. So that's why functions are so nice, is because you can make it really targeted. You're going to say, hey, assuming that I get the right material, I'm going to do one thing with it and then send it on or print it or whatever. So I'm going to say, which by the way, it tells hint a for loop might become in handy. So let's do a for loop. For I in range x, which is the thing that gets sent to us for how many times, we're going to print message. And guess what? That's all we need. I'm going to hit run to make sure I didn't have any typos or anything. But look how tiny that is. Hey, it says pineapple, and it says it 17 times. You always want to test things more than once. So somebody give me a different random word. Hello, and a different number.
92.
All right, I don't know if that's going to fit in our screen here. Okay, so it said hello 92 times, and if we scroll, it almost is hard to tell that we're scrolling, but we are. You see it happen 92 times. So that's good. We got it. Bada bing, bada boom. Okay? And the reason why you might define a function like this, because now it's there, we can use it. If in another part of this program we wanted to print something 5 times, we could say, hey, here's a new thing and here's a new number. And then it would go through here. And then we wouldn't have to be like, oh, let's copy that code from before and put it in a new slot. Nah, you don't want to do that. You don't want to repeat yourself. You want to give things nice little labels and call them up when they're needed. Any questions on that one? Okay. I want to do one more example. Let me delete this in case I open it up in another class or something. I want to do one more example of the next guy. Okay, namespaces and functions. Namespaces means when you're inside a function, you have some variables you're working with that are only in there. Okay, like in the previous one when I made that function that had message and x. Message and x only exist inside of that function. If I called it up in another function or in the loose code in the main part, they wouldn't know what that means because they only exist in there. So let's do one example of this guy. Fix this program 635 because I think it's a good one. In the editor is a buggy program for the problem outlined below. Find the bug and fix it. Following program should take two numbers and print the sum. Okay, so for this, we're going to send it two guys, and it's going to add them and then print it. Find and correct the error so the function can perform this operation correctly. Okay, so this is not going to work. If I hit run, it's going to say, wait a minute, we don't know what that means. It's going to run the function called addNums, sending it two numbers, and then those two numbers are going to be added up into something called sum. But outside of the function, when you say print sum, it doesn't know what sum means. It's trying to think that it's some like built-in thing from whatever. That they shouldn't have used a keyword for this. They should have used some nonsense word. But it doesn't reach inside of the function and fiddle with the internal workings of it. It's just like, you know, your toaster. If you put some toast in the toaster, it returns some toast, but you don't like fiddle with the inner workings. You don't like determine the specific temperature of the coils or whatever. You just put it in and get it out. You're not reaching inside and changing how it works internally. So this function, you send it something and it might send something back, but you're outside of that code. You have no idea what happens in here, okay? These guys can't reach into the function, or they shouldn't. So, how can we fix that? Well, there are lots of ways, okay? You never want to just limit yourself to one. What they probably are nudging us toward is this. You take the print sum line and just move it to right here. And so now you're printing sum where sum exists. You're saying, hey, this variable that we just made by adding two numbers, let's use it right there instead of ending the function and trying to use it outside of here where it doesn't exist anymore. So this is what they're probably nudging us toward. And if I hit run, it actually works this time. It's going to print the number that it gets from here. Okay? And that's usually what you want to do with your functions. You're going to make them just do the job in a self-contained way, and then nobody else has to even worry about like what answer it got or whatever. But there are a couple other ways to do it. Let me just show you, just for fun. Okay, so I'm going to hit Control Z and undo that. One way is something that's going to be in the next unit or the next lesson, which is called return. So if you tell it to return sum, then it's going to send it back to the person who called it. So like this line is going to get the answer. And so then we could say print this, and then it's going to go in here, do the thing, and then return that answer it got. Okay? And it's going to print 11. Okay, that's fine. That also works. It's not longer. It's not too crazy. Pretty reasonable. I don't mind that way. And you can use that once you get to 6.4 and you learn how to do the return thing. Okay, another way to do it, and this is kind of bad and we don't want to do this very often, but I just want to show you that it exists, is let's say you have a variable in your function that you want to like change it and make it available outside of there. you want to make it so that, like, hey, there's a variable that we're going to use it outside the function and inside the function, and we want it to be everywhere. Well, you can do that if you make a guy, and then you can say, hey, global sum, meaning like global variable. This is going to be used in here, and when it's changed in here, it's going to stay forever. So this variable now exists outside and inside, and if I run it, the function's going to take what was already there and change it, and then it can be used outside of there. This is not great. You don't want to use this very often, and I want to try to find better ways most of the time, but I wanted to say that it is possible to say, hey, variables are usually local, meaning if you use them inside of a guy, they're only inside of that guy. But you could say it's global and it's affected everywhere. That's the least efficient way, and I would advise against that most of the time. But I wanted to show, because I always say there are at least 3 different ways to do every problem, and there are usually infinite ways to do a problem. So what they want is for you to do the print inside. You can also have it return, and you can also do other ways. That's enough for now. This video's getting to the length I usually shoot for, which is 15 minutes. And I'll end this video, but over the next few days we'll add a few more examples and updates and things like that to help people who are on Unit 6 of the project. Thanks.